Hello, this is Group 5, and we are doing Chapter 9, Case 1, Disaster at the Denver International Airport. My name is Jamie Gleason.
I'm Denny Nguyen.
And I'm Marge Ankerson.
Our modern world depends on finding patterns and matches, on making things mesh and come together. When we shop, when we bank, when we communicate. The software that performs these tasks has to be reliable, fast, and resilient. October 1993, the new Denver International Airport is due to open. It is billed as the airport of the future, with fully automated, computer-controlled baggage handling. The 3 concourses of the airport should share a single integrated system. It would cut aircraft turnaround times, cut passenger waiting times, and cut labor costs. But there was one major problem. The system didn't work. The system was integral to the airport, but airport construction was begun before the design of the system was completed, leaving no time for simulation or testing of the full design. The system relied on 150 computers, trying to track tens of thousands of items of luggage, utilizing laser scanners, which can only achieve 96 to 97% accuracy at best. The system needed not only to error check, it needed to recover from errors fast. It needed resilience. Instead, the result was chaos. The airport opened 16 months late. The state-of-the-art baggage handling system was reduced to a system working on just 1 concourse for a single airline and handling only outbound baggage. It was a textbook case of poor system design and development. It didn't have to be that way. The trustworthy software framework would have helped the designers and users to ask the right questions, and provided a framework for delivering what was asked for, paid for, and needed. A framework that can help any project to confidently deliver reliability and resilience, time after time after time. In a chaotic world where a line of code can, like a butterfly's wing, trigger a storm, the TSI brings safety, reliability, availability, resilience, security, in a word, confidence.
Our case focused on this disaster at the Denver International Airport with the failure of the design and development of the baggage system. This disaster could have been avoided if the project managers for the new airport had done their job by requiring the proper steps be taken to modify the existing project. We are going to be going through the development stages and explaining how the Denver International Airport project could have been better handled to prevent this disaster from happening in the first place. As with anything, adequate planning and design can prevent many problems that come about because of processes that are not thoroughly thought through. Imagine a construction team building a house without blueprints, and imagine that they don't use levels or anything else that are usually used to test the stability of a home. Would you feel safe in that building? Constructing a system without thorough planning, design, and testing is the same thing. A product will be complete that no company should feel safe implementing and using while conducting their business. First was the issue with the planning phase of the system. I am not sure what development methodology they used, but I feel that the waterfall methodology would have been the best overall choice. While I am not usually a proponent for the waterfall methodology, I feel that in this case it would have worked. This is because the project was so extensive and large with so many different variables. This methodology would have forced the team to create the scope and define all requirements at the beginning of the project. and they would have created extensive documentation with these definitions. This documentation would have been signed off on, and the design portion of the project would not have even begun until all of the requirements were cemented, which would have prevented the scope creep and requirement changes that happened in this project. Development of the system would have followed the same pattern and would not have been started unless all of the preceding steps were complete. This could have prevented the disaster known as the Denver International Airport Automated Baggage System. Then there was the many issues with the design and analysis of the system. The company began being consulted with for this project. BAE had designed a much smaller version of this project for a small airport in Munich, Germany. They wrongly thought that they could use the same specs from that job to create this much larger system. This was kind of like blowing up a balloon with too much air. It worked for a while until the project burst the boundaries and exploded. Sometimes past projects can be used as starters for new projects, but because of the scale difference of these two different projects, there was no way this could have worked. There was also many issues with scope creep and changing requirements. If the project managers would have made sure that the requirements and scope were defined before the start of the project and stopped the introduction of new requirements and scope, this project would have had a much higher chance of success.
So as that video showed, testing is an essential phase in the systems development life cycle. During the testing phase, we write test conditions, we perform tests in the testing environment, and then we compare actual results from the test to results we expect from the test. And differences between the actual results and expected results show us errors in the system. So a test shows whether or not a system works. If there are any problems, the testing can help to identify those bugs or design flaws or errors in the development stage. Learning about those mistakes can help prevent future mistakes. Testing is also essential to determine how projects work by using different testing conditions, so one can identify where those issues may be as well. It is important to test a system to verify that the system functions correctly, as well as to minimize any issues in the future with implementing the system. In this case, the Delta International Airport's automated baggage system was not adequately tested, and that, along with several other factors, led to the legendary systems nightmare, as quoted in the case. The airport delayed in opening, and it cost taxpayers around $500 million as a result of not adequately testing their system. And you can see here there are different types of testing. There's alpha testing, which assesses whether the entire system meets the design requirements of the user. Developmental testing to make sure the system is bug-free. Integration testing to verify that the systems can work together with other systems. System testing to verify the units or pieces of code function correctly when integrated. User acceptance testing and unit testing as well.
The implementation phase is when the organization places the system into production so that users can begin to perform actual business operations. In this phase, a user documentation is created detailing how the system works and how to troubleshoot issues. Training is also provided for the system users and can be done online or in a classroom. Help desks are one of the best ways to support users. There are 4 different implementation methods. There's the parallel implementation, which uses both the legacy system and the new system until all users verify that the new system is functioning correctly. Then we have the plunge implementation that jumps right into the new system and disregards the legacy system. We have the pilot system, which assigns a small group of users to try the new system until it is verified to work correctly. Then everyone uses the new system. Then there's phased implementation. The new system is installed in phases, for example, by department, until it is verified to work correctly. Denver Airport used the plunge system, which could have possibly worked had they done their due diligence and tested the system. Maintenance is the process of correcting any bugs or implementing any new upgrades to the system after the initial implementation. This was not needed in the Denver International Airport because this project failed.
So as you see, we've gone through all of the steps of the system design process, starting with planning, analysis, then into design, then development, then testing and implementation, and finally maintenance. All of these steps are extremely important for the success of any project. As we saw with the Denver International Airport Automated Baggage System project, they skipped some of these steps simply because of time constraints. Skipping these steps actually made the project take longer. It ended up making the project cost more money, and it ended up creating a project that was not usable. So in order for any development team to create a project that is going to be useful and work properly, they have to go through all of these steps, no matter which methodology they use or how their development team works together. Following these steps is very, very important. So thank you for listening to our presentation. This is Group 5. Here's some of our references that we used. And make sure that you all answer the question on the discussion board. Thank you again, and we'll see you in class.